Hello everyone and welcome to the NRMCA webinar, Environmental Product Declarations. My name is Lionel LeMay with the National Ready Mix Concrete Association, and I also have as a panelist Tien Peng with the National Ready Mix Concrete Association. We'll be presenting this webinar as a team. Tien will present first and I'll present the second part. Just a few housekeeping items before we go ahead and get started. First of all, we'll be recording this webinar and we'll be uploading it to our website for future viewing. If you missed part of this webinar or want to pass it on to others. Also, everyone in the audience is muted. As you can imagine, with a large audience, with a lot of noise in the background, it would be disturbing for everyone. So we're keeping you muted, but you do have an opportunity to ask questions throughout the webinar. On your GoToWebinar dashboard, there's a place for you to type in questions, and while Tien is presenting, I'll be monitoring questions, and while I'm presenting, Tien will be monitoring questions, and so we'll decide whether or not it makes sense to interrupt the presenter during his presentation or wait till the end, depending on the nature of the question. So without further delay, let's go ahead and get started. I'm going to go ahead and transfer the screen over to Tien since he'll present the first part. Tien, it looks like you might be having trouble displaying. Yeah, it appears that Tien may have lost the internet connection, so it looks like he's logging on.
Hey, Lionel.
Yes.
You hear me? That was weird. You kind of just logged me out all of a sudden. I'm going to change the presenter, see if I can make myself a presenter.
All right.
All right. I think that worked.
Excellent.
Well, welcome everybody. This first part, we will talk about the background for environmental product declarations. I'm sure everyone has heard lots of buzz about EPDs, and so let me get started. Learning objectives for both parts is to identify what is the imperative that we are hearing for material transparency. We'll see the changes that's happened in LEED version 4, and we'll understand environmental product declarations in more detail, and understand how that comes about with the product category rules for concrete, and we'll introduce the NRMCA EPD program. So we always like to start with a why should you care, understanding the background of environmental product declarations and the drivers for EPDs. Most of all, we believe and we see from the data that it's an opportunity for growth for the concrete industry. We see that sustainability codes and standards are driving the green building market. And you can see from this graph, residential and non-residential green building market in billions has been steadily growing. And of course, they are gaining a larger share of the building market in general. You look at the non-residential green building market, and you see the yellow part is green, and the green part is conventional. That's kind of weird. And you'll see that more and more buildings are going green, as according to McGraw-Hill's research. And we see this also in a worldwide trend, that by 2015, there'll be 40 to 48% of non-residential will be green, and it'll be about $130 billion worth of construction up to 2021, where we'll see almost $300 billion worth of green construction. So certainly something we should plan for. Another driver, of course, is the competition. We see that steel has environmental product declarations. This is the asphalt EPD. This is the European EPD for ready-mix concrete. And recently released in the United States is a series of EPDs for lumber products. So clearly there is an interest, we should have an interest in environmental product declarations to compete in the marketplace. But for our specifier, it has been a confusing road towards green standards, as we see about 500 or so green labels in worldwide. And we see that it tends to confuse many of the specifiers out there. The ones that we believe that will rise to the top and that will affect our industry are some of these that I show you on the screen. LEED, obviously, the Architecture 2030, which I'll go into really briefly. Envision green roads, as well as invest our infrastructure green rating systems. And the IGCC is a new green construction code that is being adopted by a number of states. So let's take a look at LEED to start. LEED, as you know, is a driver of transformation in the building market in general to be more green, whatever that means, in different areas. LEED version 4, which is due out for ballot by its membership in June next month, had over 21,000 comments for this development compared to that is revision of the 2009 version. And so clearly lots of people are paying attention, and they want this document to be usable to the specifiers and all the construction industry that's involved. And so LEED is being one of the policies that's being adopted by a number of states. So while LEED is a voluntary standard, it is being adopted by these states and jurisdictions as mandatory for construction. So clearly it is a game changer for our industry. About 33 states, I believe, has LEED standard as a mandate, and about 250 cities and local governments have also instituted green building policies. So what's changed in LEED? LEED version 4 has evolved. LEED has always separated these attributes, these green attributes that you have grown used to and love: waste management, recycled content, locally available, renewable, and some of these other things that concrete has helped benefit, stormwater management, heat island effect. But it's changing, and they are bundling many of these attributes into a sort of life cycle approach to their credits. A life cycle approach is, in fact, probably a little bit more difficult to achieve, but it becomes more fair in terms of evaluating the overall environmental impact of any product or building, in fact. So big revisions are energy has more weight than anything. They've made the decision that energy is very important, and they are bundling all those material attributes into what's called a life cycle disclosure. So the manufacturing impact of LEED is considered through that material disclosure. So I'm going to get into a little bit of detail of the materials section. So material and resources section is we see has evolved. They've taken out recycled content, regional material, certified wood used to be its own credit, now that's eliminated, and they are more focused on transparency. That is open disclosure of what is in the material and what goes into creating a material, and letting the specifiers, the architects, the design team, evaluate for themselves, having a better understanding of the overall holistic impact of a material. So this happens, you can see how this can be the case when we talk about recycled content. You look at your, just as a simple example, if you live in a region that doesn't have recycled collection, and there are still many places in the United States that do not, you would have to either throw everything in the trash and it all goes into the landfill, or you can be a model citizen and collect your recycled materials and drive it yourself to a place that can recycle it. So that's great and all, but if you look at the impact of having everybody drive their bags of recycled material to a location, far-off location, the impact, the environmental impact that you reduced by recycling might have been offset by everybody driving. So that is the case for materials. When you look at single attributes, it's not a fair way to look at all the holistic way of looking at environmental impacts. So that's what LEED had discovered through the many years of working on their document. One of the major changes in the material and resource section is this new credit called Building Life Cycle Impact Reduction. And this will be important in a moment when I explain later. But essentially, they will take a reference building, which is if you're building an office building, a standard building, what would a standard building mean in terms of its environmental impact? And when you look at it over a 60-year span, you'll see that if you can reduce by 10% these environmental impacts, global warming potential, ozone, acidification, eutrophication, then you realize you can realize these 3 points. And I mentioned this first because what will, for the design team standpoint, this is a very difficult thing to do. That's why they gave it 3 points. Remember that bike rack is only 1 point, and brownfield development is only 1 point. But doing a whole building LCA is a difficult task if all the products in the building, which is the case today, do not have EPDs. If you have a EPD, it certainly would help understand the impacts if every product had EPDs. So they're moving towards this, you can see with this credit. In the 3 credits that are under the building product disclosure and optimization, this is where I mentioned the life cycle disclosure in the beginning of this presentation. They've broken it down to 3: environmental product declarations, sourcing of raw materials, and material ingredients. I'm going to briefly touch on all 3 of these, and Lionel will get into the details of environmental product declarations on the second half. Again, their focus is transparency, not to ding you for not being good or whatever good means in terms of the environment, but simply to be transparent and to make sure a third party has said that your declaration is true and that you are disclosing what is in the material in terms of impacts. So I'll get into detail and explain what I mean. So EPDs, if you haven't heard the analogy, I'll say it again, is sort of a nutritional label for any product. And it's been used in Europe for a number of years, but for the United States, it's fairly new. Environmental product declarations will tell the specifier what is the environmental impact of the product. And Lionel will get into the details. But for now, LEED has offered a point to any design team that can put 20 products, permanently installed products, into their building, and they get 1 point with EPDs. That is just to declare what is in it. Doesn't say good or bad, doesn't make a value judgment. And if you self-declare, if you say, I am, this is my environmental impact, without, and have it publicly available, you really only get a quarter of the product. Remember, the design team is trying to get to 20. So you giving them a quarter of a product for your concrete product, it's really not that helpful. If you offer an industry average EPD, the LEED will offer half a product. Again, the design team is trying to get to 20. Half is not great, but it's it'll help. Currently, there is no industry average EPD. Somebody can probably piece one together from old data, but this is nothing we have to offer right now. Product-specific EPD gives the design team a full product EPD, and that means for the concrete industry, a plant-specific EPD. So the plant has a concrete mix and creates an EPD from that mix that looks at all the impacts from that particular plant. That is a full product EPD. Or there's some other USGBC approved program that would help get to that. So that is the option 1. There's another option, option 2. Second option, you'll see that this is a trend for each one of these credits. They'll also give a point for optimization. That means this is the doing better than what you have declared, which is industry compared to industry average. So if you are if your plant-specific EPD shows 50% by cost, helps the 50% by cost of all the construction materials, you assist the design team showing that you have a environmental impact that is reduced below the industry average. That means you're better than industry average for your product. So you're helping the design team out by trying to reach 50% by cost. So different than the first part. But again, this is doing better. and it's the same environmental impacts as the life cycle assessment of buildings that you saw first. A little bit confusing, I know, and we will see the end result in June, but this is the way they've set up the EPDs. Final product value, in fact, is a bit of a twist that is helpful for our industry. Remember, regional material credit in LEED 2009 and previous means that they don't want people trucking things too far away, so they gave a benefit to having things that are within 500 miles. So in Southern California here, for instance, let's say you have a product that is within 500 miles, and concrete is always the case. Maybe cement as a product might not be within 500 miles, but generally concrete is a locally produced product and always contributes to that regional material. Well, now they've helped that along by saying that if you are within 100 miles, that they will give you additional value because it is a multiplication here, base product value, value factor based on attribute type criteria. That was the one that I mentioned, half value, quarter value, full value. And then that's multiplied by location. So in fact, if you have a full product EPD, plant-specific EPD, and you had the opportunity to be within 100 miles, you actually get 200% of the cost. So you are helping that design team out in terms of optimization. So they can go after that product, that second option, even more, the optimization one. So I hope that was helpful. I'll just take a brief pause if anyone has any questions on this part of this credit, which I know is a little bit confusing. Let's see. Anything, Lionel?
I'm looking at it right now. There's a question regarding could the presenter give some simple examples of concrete mixes to contrast their impact on the EPD? I think we'll get into that in the second part, where we'll have an example shown of an actual concrete EPD, and I can talk about ways that different mix designs could potentially help reduce impacts. Some occurred to me too, Tien, as you were presenting this last slide, and I guess I didn't realize that this final product value that has to do with location of manufacturing only applies to option 2 and not to option 1?
Yeah, I think so, because it's a valuation of cost.
Right.
So the first option, which is just the reporting or disclosure, is just the number of products they have to reach, which is 20. So this one can only help, I think, the second part.
Yeah, I think you're right. It's going to be interesting. I don't know why that is, and why it wouldn't just simply be 200% of the base product value.
Right.
But we'll see. We'll see what happens.
Yeah, we'll see. And actually, there's debate. I think they might bring back the 150% of cost for the 500 miles.
Right.
Because that was on the last draft. So not sure where that's going to go, but we'll see in June.
Okay.
Okay. So the second credit that I'll just briefly touch on is sourcing of raw materials. This is not having to do with environmental products per se, but more about the responsibility of our extractive industry. This applies to timber industry as well, as they are extracting from the earth. And so what they want in option 1, again, is a reporting of how well you are doing. That is how well you're treating the land, the people who are indigenous to that area, the communications, all of that. You can declare it as a manufacturer, or you can actually have a verified corporate sustainability report or corporate social responsibility report, different names, for your product. And so this is a layer of documentation that many of the multinational companies, the larger Lafarge, Cemex, Titan, they all do as a matter of course, but from the smaller company standpoint, probably have not considered doing. But having a report helps as a communication tool. So this lead wants to see this for the any of the raw material sourcing, including wood, concrete products. In option 2, just like in the first EPD credit, they want to reward teams that show leadership, and showing leadership in the wood industry is FSC, and that's always been in lead. That says we're using this certification program that says we are responsibly harvesting our timber. They still have not accepted SFI, to the dismay of the wood industry, but now it also applies to all the other industries as well, including our extractive industry. And they don't have, there is no such thing as an FSC for you know, concrete and concrete products, concrete ingredients. And so we are working hard to get the USGBC to look at one of the NRMCA programs, the Sustainable Concrete Plant Program, as one of the options to demonstrate leadership in extraction practices. Again, the valuation is there, helps out the design team to try to achieve the product. Remember, this is for the sourcing of raw material. It's only 25% by cost, so certainly helpful for the design team here. In the location-based from our industry. So material ingredients is actually the third credit and the last credit I'll talk about, but for materials and resource category, and that is new in terms of disclosing what's in the material. So you heard that the ingredients label, the EPD, the nutritional label, says what is the environmental impact. Well, this label, this reporting, is what is in it. What are the constituent chemicals inside, and this is to prevent the people who work on the building and then the tenants who occupy the buildings to have a safer, healthier air and indoor quality. And so there are a number of certifications out there, cradle to cradle, HPDs, which is new, green screen as an inventory to report what is in the material. And so, and then optimization, again, an opportunity to demonstrate your leadership by using alternate green chemistry that is not harmful to humans or life. And green chemistry, if you haven't heard of that, you know, if you have kids, there's a trend to move away from BPA in the bottles, which is a chemical that has been in lots of plastics. There's a trend also to move away from fire retardants in furniture, clothing, because that they're seeing is accumulating in the human body, especially kids. So those are what is green chemistry, moving away from that by finding alternatives to those things in creating the same material, the same performance. And again, materials helpful for if you are close by manufacturing. So those two credits we won't talk about too much because that is for another time. That is LEED. LEED has changed considerably and is certainly going to change our marketplace. Another driver for EPDs is this thing called Architecture 2030. Architecture 2030 Challenge is a sort of a dare. I challenge you to get to net zero for your building by the year 2030. Net zero carbon footprint. So Ed Mazaria is an architect who in New Mexico decided that that there's enough opportunities as buildings get torn down and rebuilt and renovated that we can, as the design community, can design better and to reach net zero energy and consequently net zero carbon by the year 2030 for our buildings. And because he sent this out and he's with the architecture community, really our specifiers, 73% of the 30 largest A&E firms that's responsible for over $100 billion in construction have adopted this challenge. And they have adopted, as well as 40% of all U.S. architecture firms. Other adoption has been the National Governors Association, Association of Counties. We see a number of states, Oregon, Washington, Illinois, all have adopted the 2030 challenge, as well as lots of other entities that are responsible for, most of the construction that goes on in our world. So the 2030 challenge for buildings, as I mentioned today, when you're designing a building, Ed Mazaria says, design it so that it's 60% more energy efficient, more carbon efficient than the standard building, and by 2015, 70, 2020, 80%, and so on until 2030, every building that is designed should be carbon neutral. And that's the challenge. And it is happening today, and many projects are achieving this. Not most, but many. Because of that, we also see that there is an increase in the embodied carbon footprint of the materials. As we see that the building's energy use is being reduced, that's the primary driver for reducing the carbon footprint. As the energy use is reduced to essentially zero, then the carbon footprint of the non-operational phase, which is the embodied, starts to grow. So because of that, the 2030 challenge said, how about a 2030 challenge for products to get the products to reduce their carbon footprint? This is the same goal by 2030 to get to 50% of the embodied carbon footprint. Today it would be, by 2015, 35% or better. So how is this achieved? The way to achieve this is to understand what is the carbon footprint of a material, and that is achieved through an EPD. And so an EPD will show the carbon in quantity in a product based on their embodied footprint, and it is, Lina will go over it, expressed for the global warming potential. Other industries driving this, the Green Construction Code has a life cycle assessment that an EPD easily plugs in for the building, very similar to the first credit I mentioned in LEED. That was 3 points. Infrastructure-wise, green, it's not just about green building. We see the drive for reduced carbon footprint of materials in other rating systems for infrastructure. This one is similar to the responsible sourcing credit here, support sustainable procurement practices. This is in ISI Envision. And so I'll stop right there as my time is up, but safe to say that EPDs are the future of what we see for our materials, and as an industry we have two choices, and that is to get on board very early on to sort of mold our own future, or we could wait for other industries to set our future for us, and we've elected to choose the former. Lina will go over some of the exciting things that's happening in the concrete industry for EPDs. And I'll stop right there. If there are any other questions for now, I guess we'll see. We'll see more details soon enough.
All right, Tian. Excellent introduction and nice segue into my part. I don't see any questions, so go ahead and push forward. If you could just transfer the screen over to me, I'll take control and we'll get started. All right. Okay, so this is the second part where we'll get into some detail about environmental product declarations. Tian, I think, laid out all the good reasons why the industry is even looking into environmental product declarations. I think what happens a lot, and I've experienced this myself personally, because I'm the one, or Tian is the one, delivering the information about environmental product declarations, the first reaction is, why? Why is the industry doing this, and sort of blaming the messenger? Well, in fact, it's the lead and those green designers out there that are moving towards this concept of environmental product declarations, and so the concrete industry has listened and tried to develop a pathway, try to break down some barriers towards meeting these new criteria in LEED. So let's get into some of the detail. All right, so this is an image that tries to describe in very short or very succinctly what an EPD is all about. So environmental product declaration is a document that I like to call an executive summary of a life cycle assessment. Basically, it takes a very long report that was done using a scientific method called life cycle assessment and puts it into a shorter document that simply provides a summary of the life cycle assessment. Basically just listing the environmental impacts of a product or process. An LCA is conducted using a product category rule. A product category rule sets the standard by which every product in a certain category conducts the life cycle assessment. So what is a product category? Well, concrete could be a product category, carpeting could be a product category, ceiling tiles, wall coverings, doors, wood products, you name it. Or doesn't even have to be a building product, right? I mean, these EPDs were developed not just for building products, they were developed for all sorts of consumer products as well. So it could be an EPD for, or a PCR for printers, or for soda bottles, water bottles, whatever. And an LCA, what's really important about a life cycle assessment is that you have life cycle inventory data that is as specific as possible to the manufacturing location and the products being used in the manufacturing process. There are 3 international standards that set the rules basically for conducting and producing environmental product declarations, type 1, 2, and 3 EPDs. We're going to focus on Type 3 environmental product declarations because that's what most of these standards have been referencing. So ISO 14025 that requires a third-party review of the life cycle, of the EPD, which basically, as Tien pointed out, is a nutrition label, in a sense, for products. So here's the comparison. If you see on the left, you'll see a nutrition facts for food, basically laying out things like calories and fat and total carbohydrates. On the right, you see a table that lists the environmental impacts for a product. And you'll see that it just simply has, here I'll show you with my highlighter, a list of the impact in units for different environmental impacts, such as acidification, eutrophication, global warming potential, ozone depletion, and smog and air. And there are other environmental impacts. This table just happens to list these 5. In brief, what a life cycle assessment is, it's really a technique to assess the environmental aspects and potential impacts associated with a product or process or service. It's part of the ISO International Standards Organization 14,000 Environmental Management Standards. And basically what you do is you, through each process of the manufacturing of a product, you would measure somehow emissions to water, air, land, and then characterize those emissions in some way that would indicate certain environmental impact as a result of those emissions. And what's important is that you include all of the steps in the process. Now, for a cradle-to-grave type life cycle assessment, you would go all the way from extraction of raw materials through the manufacturing process, through transportation of the product to the different stages of manufacturing and construction for construction products. And then the use phase, there are impacts throughout the use phase, maintenance perhaps, or other processes throughout the entire life cycle that you need to take into account. And then finally at the end of its useful life, whether it's landfilled, recycled, reused in some way. You can do life cycle assessments for shorter periods or fewer of the life cycle stages. So a lot of times, especially in this period of time, most products are doing life cycle assessments for cradle to gate. In other words, extraction of raw materials, transportation to a plant, manufacturing of the material itself or product to the point where it leaves the plant site. Product category rule sets these standards, right? Basically providing instructions to the life cycle assessment professional conducting the process, the life cycle assessment itself, to identify things like what product's being studied. So, you know, the functional unit, for example, for concrete, it could be a cubic yard of concrete or cubic meter of concrete. It could be a square foot of floor area. For shampoo, it could be a 1 liter bottle of shampoo, whatever the functional unit is. It also sets the system boundaries, what life cycle stages are included in the process, the life cycle assessment, and what impacts are being reported in the EPD. What it does is it allows for comparisons of one product to another, apples to apples, concrete to concrete, wood to wood. And it was, you know, the whole idea of life cycle assessment was really developed as a way to improve a process. So in other words, if you're looking at your manufacturing process and you are looking at, you've conducted a life cycle assessment, you can do what if scenarios. What if I change that process? What if I use a different product in the formulation? What if I change out electric motors to be more efficient, and see what impact it has on the environment, and potentially make changes to improve environmental performance. It tries to eliminate things like comparing apples to oranges, a yard of concrete to a ton of steel. clearly those are not equivalent products. Now, you could, through the use of an EPD, let's say for a cubic yard of concrete and a ton of steel, you could potentially conduct a life cycle assessment that would compare, let's say, a beam that was supporting a certain load made with concrete versus a beam supporting a certain load made with steel. Now, what you really need to make sure of is that they're entirely equivalent. For example, concrete generally is self-fire protecting. In other words, concrete cover over steel reinforcement provides its own fire resistance. Steel, on the other hand, does not. You would have to include fire-resistant materials on the steel beam to make it a completely equivalent comparison. And so if you had a PCR for steel, for example, likely it would not include the environmental impacts of the fire protection. So you would have to go somewhere and find other life cycle inventory information about the fire protection to do a complete comparison of the two different systems. What about a PCR for concrete? Well, there is one. In fact, there are two. The one I'll talk about is the one that was developed here in North America. There's a second one that was developed in Europe. But this is the one that is most appropriate for use in North America. It was developed by a group called the Carbon Leadership Forum. Started the process about 2 years ago. Well, the Carbon Leadership Forum is made up of these groups here. You can see there are concrete interests in this group. There are designer interests. Life cycle assessment professionals are involved in this group. And they started the process of developing a PCR for concrete. They included in the PCR committee to develop this PCR, again, several people from the concrete industry, including myself, John Oxendorf from MIT, some other life cycle assessment professionals, some design professionals, other people from the concrete industry, Jeff Davis with Central Concrete, Greg McKinnon with Stoneway Concrete, and so forth. So a wide variety of interests were involved in this committee. It began in 2011, May of 2011, and took about a year and a half before the final version in November 2012. Fairly fast for a standard like this, although it could have been faster. There were the ISO standards require at least one public comment period where people in the general public can comment. And in fact, in this case, we had 2 public comment periods just to make sure that we had feedback from potential interested parties. So it took a little longer. And it's a document, it's a standard. In this case, it's about almost 50 pages long. It's fairly complex. Really, LCA professionals understand these documents. If you're reading it for the first time, some of the information will likely be a little foreign to you, but I'm going to try to break it down into its basics here in the next couple of slides. For example, the declared unit or the functional unit, if you will, it's really a declared unit in this case because a cubic yard of concrete really doesn't have a function. It only functions when it's turned into a slab or a pavement or a beam or a column. But in this case, this is a declared unit of 1 meters cubed, and we use metric units because that's basically throughout the world, life cycle assessment is done generally using metric units. Optionally, you can report in U.S. customary units. You need to declare or describe the product using compressive strength with optional other descriptors like exposure class or design slump or slump flow and other performance characteristics. But at least you have to describe the compressive strength of the product that you're basically declaring in this EPD. Life cycle stages, it only does life cycle stages A1 through 3 and A4 and 5. Okay, so at the very least you have to do cradle to gate. This is life cycle stages A1 through 3, and optionally you can add the construction process stage, actually just A4, which is transportation to the construction site. Most would just do a cradle-to-gate EPD. One thing interesting about EPDs, if you're only doing a cradle-to-gate EPD, you can only use that EPD for communicating business to business. You are, in theory, not supposed to use these EPDs for communicating this information to consumers. When you do a true consumer EPD, it would be from cradle to grave. So in this case, because it's a cradle-to-gate type EPD, it's used for submittals to design professionals on a project and so forth. It describes in this PCR the system boundaries, what's included in the LCA, and there's some notable items that are not included in the life cycle assessment, and I'll describe those in a second. But one thing to point out is that you do have to include all upstream processes, right? So you'll see natural aggregates, crushed aggregates, cement, all the extraction and manufacturing, supplementary cementing materials, water, admixtures, all of these products that go into making concrete, you have to include the impacts of extracting and manufacturing those products. So what's excluded from the system boundaries? Things like production, manufacturing, construction of buildings, right? So on a plant site, you have buildings that were constructed many years ago, likely. You don't have to include those in the life cycle assessment. Things like equipment, earth-moving equipment, trucks, lab equipment, and so forth, manufacturing equipment, don't have to be included in the LCA. And other things like personnel-related activities like travel and furniture and office supplies don't have to be included. You could imagine where this LCA could become extremely complex if you start including all the impacts from all these other, from the sort of the permanently installed products or manufacturing equipment and so forth and buildings, because now you would have to expand your LCA to include those products and try to allocate impacts from those systems into the impacts of the product. So generally this is the way PCRs are written. You can not include some of these other permanently installed buildings and activities. The PCR is somewhat unique in that it has two types of EPDs, one just for reporting global warming potential, and then the second option, which is a completely ISO compliant type 3 EPD. Well, why was this done? It was done because this whole process of developing the PCR was an outshoot of the Architecture 2030 challenge for products, which only is asking for global warming potential. ISO compliant type 3 EPD asks for significantly more environmental impacts. That includes global warming potential, but also other information like water use, total primary energy use, ozone depletion, acidification, and so forth. Most EPDs for concrete would probably go the ISO compliant type 3 EPD route. Optional additional information that could be reported, all host of different environmental impacts and information about the product. One thing that's somewhat unique about this PCR is that it tries to lay out a hierarchy of data sources that would be used to produce the EPD and conduct the life cycle assessment that is done before the EPD is produced. So this is the list that's in the PCR, and it favors, higher up the list is more favorable than lower on the list. But you use whatever is best available. So in other words, if you go to the top of this list, plant-specific EPD results. So if you're conducting a life cycle assessment on a concrete plant, you would look at all the suppliers and ask them for their EPDs, right? So cement, fly ash, slag, admixtures, aggregates, and so forth. Ask them, do you have EPDs? Likely not at this point in time. So you would go down the list even further. Okay, so company weighted average EPD. So maybe there's a company out there let's say a cement company that has 10 plants around the country, they might have a company-weighted EPD, a weighted average for that plant. You could use that information in conducting the LCA. And further on down the list. At this point in time, most people would likely be using publicly available data for LCAs. There are also very important distinctions regarding allocation assumptions for upstream products. Specifically, things like emissions from waste incineration, let's say tires and other waste materials that are used for manufacturing cement, for example. You don't have to include the impacts from the original manufacturing process. So you don't have to include the impacts from manufacturing tires when you're using tires as fuel for making cement. Now, if there's some processing involved, let's say chopping up the tires or transporting them from one location to another, to your plant, you have to include those impacts, but none of the impacts as a result of manufacturing. Similarly with supplementary cementing materials, this is really important. So, for example, emissions from coal power or from steel manufacturing don't have to be included when you're including things like fly ash and slag in concrete. Now, again, if there's some processing involved, in some cases there's some beneficiation for fly ash that would require some processing, yes, certainly you would include that. Or slag cement, same thing. Usually there's some processing involved. Well, not usually, always there's processing involved. You have to include those impacts, but not the impacts of the original manufacturing process for steel or for electric power, for example. Contents of the EPD, very basic information that has to be included: the name and address of the manufacturer, the description of the product, the description of the main components of the product, name of the EPD program that was used to verify the EPD, date the declaration was issued, and that it's valid for a period of 5 years, which life cycle stages were not considered, and then a statement regarding the data quality and variability of the data. And one thing that's always the case for life cycle assessment is that there's significant variability in the data for several reasons. One, collecting data always results in some variability, right? Because you're not going to get the same result every time you measure something. And then there's also the sort of uncertainty from the fact that you're getting data that might be averaged out over a year or over a region, and so or over manufacturers, right? So you might have 3 different cement manufacturers supplying cement to you. You would have and each one of them, those cements, has a different impact profile. You would have to make some assumptions about percentages of each one of those cements that you use in concrete on average, but because you're using an average, there's going to be some variability, and you have to make that statement in the EPD. This is a table. Don't really pay attention to the numbers. They're just numbers that are thrown into a table to give you an example of what this table might look like as part of the EPD. It's just one page in the EPD. But this is really what most people would go to right away. Most of the preamble describing how the LCA was conducted and how the PCR was followed and the standards were followed really lead to this table where you can look up the environmental impacts. The EPD document is a marketing document or a document that's used for submittals on a project. It can be anywhere. I've seen some as short as 3 pages. I've seen some as long as over 40 pages. Here's an example of one from the carpeting industry. Bentley Sprint Street Carpeting. It's one of the ones that's used, well, that I use oftentimes as an example, a good example of what a PCR, what an EPD should look like. Always has a cover. There's a page that describes the basic information that is required as part of the EPD and who conducted the life cycle assessment, who verified that the LCA and the EPD meet all the standards and so forth, who this EPD belongs to. It's the manufacturer that owns this EPD. a description of the product and so forth. So that one page usually comes right after the cover page. And then you get into some of the detail of the product, describing what the product is made from, what it's used for, life cycle stages that were included and which ones were not. Some other information, a lot of times these graphics are included or not. And then here's the table that I talked about. This is the table that describes the life cycle impacts. And then there's also some other environmental information that oftentimes is communicated, all of which needs to be verified by another life cycle assessment professional that is actually third party verifying this information. So you can't make any claims in an EPD that, you know, basically greenwashing claims. Hey, I'm the best manufacturer, green manufacturer of carpeting. You can't make that claim unless you have something that backs it up. You know, if some organization actually declared you through some process as the best carpeting manufacturer, yes, you can make that claim, and it has to be third-party verified. You have some sort of a certificate or a letter or something that says you are the best or one of the best or won some award or have some other certification. Yes, you could make that claim as long as you have the backup that can be third-party verified. But here's one thing that's interesting. And I realize it's hard to read, and we'll have an example later on that's probably equally hard to read, but we'll look at a magnification of the table, where in this case for carpeting, you can imagine that a carpet line might have different carpet weights, right? Not every carpet is the same weight of yarn, and so in this case what they did is they included this table that had different yarn weights here at the top and the environmental impacts for each one of those different yarn weights. So they were able to cover, oh, I don't know, what's that, 15 different carpet weights for the same product line. So the question is, can we really do this for concrete? It's you know, every plant has thousands of mix designs. You might be developing new mix designs for a new project. Oftentimes, every day you're probably creating new mixes specifically to address different criteria or the challenges of weather, changes in weather, or changes in product suppliers and so forth. So you have to, well, there's a challenge obviously with concrete. It's similar to what we just saw for carpeting, except for carpeting you might have 15 different yarn weights. For concrete you might have thousands of different mixed variations at a plant. Do we have some of the upstream data that's needed to do the LCA? How much will it cost to conduct these life cycle assessments, and how long will it take? Likely this won't happen in a matter of days. It'll take weeks, sometimes months, to create an EPD for concrete. Now, NRMCA decided that they would become an EPD program operator. Program operator does things like certifying or verifying EPDs. They review life cycle assessments, and they develop product category rules. And we try to be consistent, as we are required by international standards, with other EPD programs. Part of the reason we did this is so that we could help the concrete industry ease their way into the whole EPD process, help streamline it, if you will, define what an EPD for concrete might look like. And the process is complex at first, although it's not dissimilar from any other certification process, really. So as a product manufacturer, what you would do is you would select the PCR to conduct your LCA from. The LCA, to be valid, needs to be critically reviewed. Then from that LCA, you need to produce a draft EPD. You submit the LCA report along with the draft EPD to NRMCA. You don't have to use NRMCA. You can use, there are other EPD programs out there that you could use to verify an EPD. Then what we do is we use third-party verifiers to verify that the EPD meets the international standards and the PCR and the program operator rules. So each program operator has a set of rules. Most of them are very similar that need to be followed to develop EPDs under that program. Presumably, and the international standards point to this direction, is that once a PCR is created, that other EPD programs adopt that PCR, review it to make sure it meets the EPD program rules, but then adopts that PCR so that no matter where an EPD is being verified or which program is being used, that the EPDs are all comparable. The certification process, you're submitting the LCA report. You can either have it already reviewed by an independent reviewer, so you can find an LCA professional to do the LCA and find another independent reviewer, or you could have NRMCA review it. We have a process whereby one of our independent reviewers can do the review of the LCA report. Just a point I want to make here is that the LCA report often contains proprietary information, things like mix design, other processes that might be proprietary to your plant. And so the LCA report rarely gets issued publicly. It stays private, even though you're submitting it to an independent reviewer. They don't distribute it to anybody. The original LCA professional that conducted the LCA report, they don't distribute it. It's kept confidential. When it's sent to NRMCA, we maintain confidentiality. It's the draft EPD that gets publicly issued once it's been verified. So you submit the draft EPD along with the LCA report, and you submit using we have a submittal form and a fee that you need to submit using our process, just like any other program operator. The NRMCA consultant conducts this, NRMCA conducts an initial review. So we take a look at it, make sure that it meets our criteria, but we don't do a thorough review. But if it needs some corrections, we'll send it back to the submitter to have them make initial corrections. Then we send it, once it's corrected, we send it to now an independent verifier who does a very thorough review of the LCA report and the EPD. NRMCA, we're not LCA professionals. That's why we use, and we want to maintain this third-party concept where someone outside of NRMCA is making the review. And this is pretty common with most EPD program operators. We've published a price or a fee schedule for conducting critical reviews of LCAs and independent verification of EPDs. You can see it here. We have, for members, NRMCA members, the cost is less than non-members. And we have different levels of certification. So if you want us to do the critical review of the LCA and independent verification of the EPD, it costs the most because it's a pretty significant effort. If all you want is the EPD verified and you already have a critically reviewed LCA, then it's much less. So, it would cost you only this much. And then there's, if you're basically adding on to an existing EPD based off the same LCA, it's even less than that. I will say this, that likely these costs will increase because, we started out with this fee schedule, but as it turns out, the process of reviewing the LCA and conducting an independent verification of the EPD is going to cost more based on our first experience here with verifying an EPD. The independent reviewers are Athena Institute, Carbon Sense Solutions, Climate Earth, and NSF International. These companies can also conduct LCAs. You can contract directly with them to conduct the LCA, or you can use any other LCA expert out there. And there are several. you could just do a Google search for LCA experts or consultants, and you'll get different companies. These just happen to be the companies that agreed to work with us for that fee schedule. Certification comes when the verifier can verify that the EPD meets the ISO standard, meets the PCR requirements, and meets NRMCA program rules. We did just recently verify our very first EPD. It's the very first EPD published in North America. So as part of a program operator, we are obligated to publish this EPD, make it available for download on our website. Obviously, the company owns this EPD, so they publish it on their website as well. I'll just show you a few pages of this EPD. This is the cover page, describes the company, which service areas covered by this EPD. This is a fairly large EPD. Okay, basically it covers over 1,400 mix designs produced at 8 different plants in the San Francisco area. Central Concrete is the one that actually commissioned an LCA professional to conduct the LCA and produce the EPD. This is the inside page that provides all the detail about what was the declared product, what's the declared owner, the program operator, the developer of the EPD, Climate Earth, independent verifier, Athena in this case, product category rule used, date of issue, date of validity, and a number, EPD number. It provides some background data. I'm not going to go through this in great detail. You can actually download it from our website and read it in great detail, but basically all the information that's required in the PCR. This is all background. This is data quality, information about data quality and the variability. In a table, it describes what that is. Then describes the components of the concrete, basically cement, fly ash, slag, aggregates, admixtures, batching water. And then, again, what's really important here, right? This is all about environmental impacts. It also describes references, where some of the data was gathered from and so forth. And then this is the important part. This is an appendix. This is the way Central decided to describe the impacts. It has a table up front that has abbreviations. You can see you'll see in the next slide the table is extensive, over 1,400 mix designs, so the table is large. And so to make the table fit, they had to use standard abbreviations for these different impacts. And this is the table. This is one page of perhaps 30 pages of different mix designs, and you can see it's organized by plant, and then compressor strength, and then the list of impacts. Here's a magnification of that table, just listing a few of the different mix designs. Now, you notice that the mix design is actually not provided in the EPD. All that is provided is the mix code. So a design professional would, if they asked for an EPD on a project, would get, of course, the typical mix design submittals with the product mix code listed, and they could go to this table and find the mix code and look at the environmental impacts. So here, TPE, total primary energy, concrete water use for batching and for washing, global warming potential, ozone depletion, acidification, eutrophication, and potential ozone creation or smog formation. So each one of the mixes, besides the mix code, has a strength listed, and then every one of the impacts, a value for the impacts. So that table previously showed what units these are listed in as well. And this goes on, like I said, for 30 pages. It's unique, and that's what's unique about concrete, right? Carpeting had 15. Concrete has hundreds. Let's put this into a bigger perspective, right? You know, why are product manufacturers now being led towards this idea of developing these EPDs or transparency or declarations? You know, life cycle assessment can apply to any product or process. So you can imagine for a building, hundreds, perhaps thousands of different products are used in that building and processes, heating and cooling the building, water use, other resources throughout the life. And so you can conduct a life cycle assessment on a building. Just to step back, there are very well-defined components of an LCA that includes goal definition, scoping, you know, what products you're analyzing and so forth. Very much like a PCR. You almost need a PCR for a building LCA, which in a sense, in fact, is being worked on by ASTM and the ISO standards. You have to do an inventory analysis. In other words, that basically provides you with all the emissions that occur during that process. You do the impact assessment, which is converting those impacts, the inventory of emissions into impacts. And finally, you interpret the results in some way. Each one of these emissions provides a stress on the environment. And the key is to take those impacts and somehow interpret the stresses on the environment. Well, you need some sort of a guideline to do that. And identifying stressors basically is going through this life cycle process, looking at each life cycle stage and identifying the outputs, and then using some process to prioritize those impacts once you determine what those impacts are. But still, it's not real clear how you go from emissions to impacts, because knowing how many, how many cubic meters of carbon dioxide are emitted to the atmosphere doesn't really tell you much. You need to be able to know, well, how much, what effect on global warming what potential effect will global warming or the carbon emissions have on global warming? That's what's you need to know. Or what effect does the emissions of sulfur dioxide have on smog formation or acidification, let's say. So there is a process here for doing that in the U.S. Called TRACY, which is the Tool for Reduction and Assessment of Chemicals and Other Environmental Impacts, that developed by EPA. And so what you do is you take those emissions, you look at converting those emissions into environmental impacts. And basically it's just a table that characterizes those emissions into potential harm to the environment. Oftentimes we get the question, well, what about ingredients to a product like concrete? Do they need EPDs? In theory, they don't necessarily need EPDs because you can create an EPD for concrete or any other product as long as you have life cycle inventory data about the components or ingredients. It would make things a lot easier, obviously, if we had EPDs for the ingredients in concrete, because then that data would be easily plugged into the concrete EPD. And I think there's some benefit, you know, when a company asks their product suppliers, do you have an EPD for your product? And they say, yes, here it is. Clearly there's a benefit for that company as compared to a company that does not have an EPD. So I think there's some market advantage for suppliers that develop their own EPDs. And then when you take those other EPDs for different products, you can plug them into the larger LCA for whole buildings, which is the ultimate result we're trying to get at, right? One thing to remember, and Tian brought this up, is that EPDs focus generally on a pre-use phase, right? Extracting raw materials, manufacturing the product, transportation to the plant site, and so forth, which only, according to Architecture 2030 and other research, confirms this, that the impacts today only comprise about 5.5 to 8% of environmental impacts for global warming potential. Might be larger for other impacts. The use phase of a building has much larger impact, 92 to 94.5%, according to Architecture 2030. As they point out, as we get closer and closer to zero net global warming potential for buildings, the impacts from the products themselves will have a higher impact proportionally then. So it's important to look at environmental impacts of products. Now, just in conclusion, as a reminder, why is NRMCA doing this? Providing a service to the industry, again, trying to make this process easier for our members, for those who would like to participate in green building projects when LEED version 4 becomes adopted, concrete can still compete. Helping members meet these new requirements in LEED and Architecture 2030 and other environmental guides and standards. Ultimately, helping grow the pie for concrete, which is ultimately what we're trying to do. Make it easier for concrete to be used in a product. Make it the sustainable building material of choice. All right, that concludes my part 2. Tian, I don't know if you seen any questions.
Yes, a number of them. I guess the only one that I just want to confirm is that the age of the compressive strength, is that 28 days, or is it noted anywhere on the document?
Yeah, in theory, you're supposed to indicate strength at what age. So, in some mixed designs that were specifically, say, designed for low environmental impact. Oh, yeah, and that actually will now answer the question that was asked earlier during your presentation is, for example, if you use high volumes of supplementary cementing materials, which is generally how impacts are lowered on a specific mix. Not the only way. I'll explain other ways in a minute. Of course, once you use higher volumes of supplementary cementing materials, strength gain is delayed. Therefore, you could indicate a strength at a certain age, beyond 28 days. Maybe it's 56 days or 90 days or whatever the number is. So yeah, you would indicate that. Now, using different formulations for concrete, to change the environmental impacts is, often used. But that's not the only way. For example, I think everyone understands that, so let's say certain cement plants might have an older manufacturing process compared to, say, newer, more state-of-the-art plants. And so one could lower impact by using cement from a plant that is state-of-the-art, because it would have, in theory, not in theory, actually, a lower impact, maybe as much as 50% of the impact of a plant that was, using an older manufacturing process. So that's also something to consider.
But that wouldn't be expressed in a designer, a design professional couldn't see that except just looking at the impacts that is documented from that plant as opposed to another plant. It would just be like the designer wouldn't know that the benefit comes from either SCMs or from the manufacturing process. They would just see that the impact is lower on the EPDs.
That is correct. One thing, so that only addresses option 1 of the new LEED standard, right, for environmental product declarations. In the future, and we are, NRMCA is trying to accomplish this through a research project. We don't have approval yet to move forward on it, but we're working on a program whereby we would produce as an industry average EPD, and then from that also develop industry baselines for different products, whereby you could compare your product to that baseline, thus addressing option 2 in the LEED version 4 credit. So you could demonstrate that your product was below the industry average for certain environmental impacts. Any other questions?
I don't see any more questions.
All right. Well, with that, we'll sign off. Just a reminder that you can go to this website to get information about NRMCA's EPD program. You can also view the recording. You can download PDFs of the presentations both Ken and I presented today. You can also download the concrete EPD that I showed you from Central Ready Mix. All right, with that, we'll sign off. Good afternoon or morning or evening, depending on where you are.
Thanks very much.
All right, bye now.
Bye.
The organizer